Welcome to Summarize Science, where we break down the latest breakthroughs in technology. Today, we are looking at a paper titled iTryOn, which explores the next frontier of digital fashion, interactive video try-on. While we have seen AI put new clothes on people in photos before, doing so in a video is much more difficult. The researchers identified a major gap. Most current models only work when a person is standing still or moving passively. In the real world, we do not just wear clothes. We interact with them by adjusting collars, pulling on hems, or unzipping jackets. As seen in these examples, iTryOn aims to make digital clothing react realistically to these specific human actions. The team formalizes this as a new challenge called Interactive Video Virtual Try-On, or Interactive VVT for short. This task is incredibly complex because the AI must preserve the texture of the garment while it is being stretched or moved. One of the biggest problems is what they call interaction ambiguity. Standard 2D pose data can make it hard for an AI to tell if a hand is moving toward the chest or just across the body. Without depth cues, the AI might miss the signal that a hand is about to touch a button or a zipper. Furthermore, interactive moments in videos are often very brief, making them hard for the model to learn from. To solve the data problem, the team curated a massive new dataset called VVT-Interact. They collected over 5,000 high-quality video garment pairs from e-commerce live streams and social media. They then used advanced AI models to label every frame as either interactive or non-interactive. This allowed them to provide the model with precise start and end times for every single action. The architecture of iTryOn uses a 3D hand model to give the AI a sense of spatial guidance. This 3D prior tells the system exactly where the hand is in space, so it can render the contact point accurately. By using a 3D representation rather than a flat 2D depth map, they avoided visual artifacts like hands merging into sleeves. They also used something called action-aware rotational position embedding to synchronize captions with the video frames. The researchers also developed a specific loss function to help the AI focus during its training phase. Because interactions are rare compared to normal movement, the AI might otherwise ignore the complex physics of a zipper or a tugged hem. This focus training approach forces the model to prioritize those critical, split-second moments of contact. They also introduced a new metric called the interaction success rate to measure how recognizable the final actions are. When comparing iTryOn to other state-of-the-art models, the results were striking. The researchers found that iTryOn achieved significantly higher visual fidelity and better temporal consistency. Crucially, it outperformed all other models in terms of interaction success, with a rate of over 61%. Other models often generated plausible-looking frames, but failed to actually execute the specific physical interaction requested. Even with these successes, the paper notes a few interesting limitations for future study. For example, if you ask the AI to perform an unzipping motion on a t-shirt that has no zipper, the model will pantomime the action instead. The AI does not yet fully reason about garment semantics, like knowing if a shirt actually possesses buttons. Improving this kind of logical reasoning is the next big step for the research team. In summary, the researchers have created a way for digital clothes to move and react just like real ones during human interaction. By combining 3D hand data with precise action captions, they have set a new standard for virtual try-on technology. This could mean a future where you can truly see how a jacket fits and feels to use before you ever click buy. It is a significant leap toward more dynamic and controllable virtual experiences for everyone. Thanks for watching Summarize Science, and stay tuned for more breakdowns of the latest research.